very simplistically, the point that you mentioned about the balance between computation and memory. So can I kind of take that, okay, language learning in this perspective is to find this balance between how much I should store in my memory, how much I should learn the rules to connect things together. So, but learning company, can you imagine that looking at our data while people are learning a language could be useful also to bring in the context of this this whole model and campus?
Yes, although I mean it depends on. Yes, it depends on what exactly you mean. So I mean you can use these models, for instance, to try to figure out what the sort of lexical state of people are at various points in time. Now you probably don't have enough data for an individual to do that, but at like various for classes of individuals probably coming from a particular linguistic background at a particular stage of learning, you probably could actually build a fairly accurate model of what the typical belief state is about the target language at that time, and that might be useful in various ways. Another thing that this will probably be useful for, by the way, is you can use this to determine what lexical constructions. So it's pretty clear that people when you use English, or when I'm using English here, I'm for the most part as an expert English speaker relying heavily on very, very large sort of lexical constructions, most of which could be decomposed. When I first started learning it, I presumably did that, and it can be decomposed. But of course, you have a lot of sort of fixed grammatical structures and fixed lexical structures that you reuse, which I'm guessing actually, if things were actually targeted specifically to teach people these, the most useful ones earlier would actually be a much faster way to learn languages. I mean, there's various pieces of research on this, but yeah, that's another thing you could use this kind of thing for.
I was interested in the separation of the stemming of your words. How does the learning, because actually there are some that just take Asian as one, then you have this ification, however this is done. And how is that, when you have different stemmings in there, is the learning different? I don't know actually how this is done.
So I mean, I had to make various decisions about this. So what I did is I inverted all the regular phonological processes. Like, that's a regular process in that context, right? So you always, if you want if I have a word like stultify, it's always going to be stultification. And so what I did is I inverted all those phonological processes. So I got rid of them, and then I merged all the morphemes that could be plausibly identified as the same morpheme. Because as I said, in this particular set of projects, I wasn't interested in learning the phonology of these morphological processes. I was just interested in studying the question of how the distribution mattered. And so I erred on the side of kind of making everything collapsed and as pretty and as straightforward as possible. I have some thoughts about how these things could interact. English is not the right place to study that, but.
Just to go on with the learning, because actually if you split things into these very separated, or try to separate as much as possible, then it's hard to teach that to somebody, because sometimes you just don't hear that there is this Asian thing.
Well, I guess this is exactly the point I was just making, which is that, for instance, in the case of, so you run this model here, and then you get these particular things are stored as whole. Well, of course, these are exactly the things you want to teach people as single units, because every native speaker treats them as a single unit, right? But you can use it. But this, of course, in these cases for ification is trivial, because you already know that must be the case because it's pronounced funny. But there's many cases, of course, where that's not true, where you have some syntactic constructions, say, which you can teach in a decomposed way, but you probably should teach as a single unit.
So everybody is free to stick around for questions, but you should also know that now you are free to go. But I encourage you to stick around for questions, or pizza and so on. But so you know.
Thank you very much.
Pretty like informal maybe. So maybe maybe have some more like chairs closer clustered or something like that. It's a very like one-sided speaking oriented format right now. But I don't actually have anything planned in particular. So
But if you plan on sitting,
yeah, whatever. It's true. Half of these resistance. Do you want to sit down? Yeah. You can sit down. Now it's more fun. Alright. Okay.
I was actually wondering, you predict the predictability or productivity of suffixes. Do you also take a look at the consonants of the words? Like if there are plosives or fricatives, and which of the suffix would be most efficient to...
No, so in this work, I have some work on that kind of thing, but in this work I didn't model any phonological structure whatsoever.
Okay.
So not so much in derivational morphology, but in inflectional morphology, of course, there's a lot of allomorphy. But you know, for instance, I didn't model. Oh no, I actually did model that. Like for, you know, if I applied this to the English plural, for instance, I wouldn't have modeled the phonological rule that says that after unvoiced final stop that you you use s versus.
Cats and dogs.
So I didn't try. So I have work. So you know the thing is that inverting these kinds of phonological rules is a separate and quite challenging problem in itself. I mean, there's some work on that. I've been building some models that integrate these two things and try to learn them simultaneously. But then you need much more powerful inferential tools, basically, is what it is.
True. I was only wondering if you have like 2 new words and you're telling people to decide which one they like better if they don't like one form better because of where consonants being.
Oh, so you're asking. Basically, are the experiments that I talked about confounded?
Yeah.
And the answer is no. I'm just going to stop there. No. So the experiments that I reported, these were they like Idi and Ness experiments, for instance. All of the roots were constructed by hand to be maximally phonologically plausible. That's why the things like remortable, which sounds like it very much. So you know, if, for instance, attaches to Latinate, to words of Latinate origin. I can't think of any Germanic stems.
No, there's no Germanic.
Yeah, I don't think there's any Germanic stems here. So all of those have things like remortable, which sounds like it. You know, it does use a couple. It's like I don't know, rediable or something. If you actually try to assign a meaning to it. So, but yeah, it's trying to control for that stuff. Yeah.
Okay.
But doesn't the L in the end of remortable alone cause a bias towards remortability? Because ability is such a thing, like.
Well, yeah, but that's exactly the point because that's exactly the point, right? So, able is just preferred to attach to ability, as opposed to if, which prefers to attach to ness. But idi is not generally something you can use productively. I don't think it's not the L that prefers idi. There's a suffix there which is able, which prefers to go with idi. Mind you, that's like I don't think it has much to do with the existence of the word ability. Because prior to 1955 or so, that speakers would have preferred more speakers preferred remortableness, and remortableness is completely fine still, of course, but I don't think it has a lot to do with the existence of the word ability. I think it has to do with the existence of lots of words that are being made up all the time, and mostly in television commercials about things like drinkability and smokeability. Well, probably not that.
Do you have an explanation why unproductive morphemes are still sometimes used to form new words? So something like warmth?
Yeah, why you get stuff occasionally like wolf or something like that, yeah. So it depends on what you're asking. So one of the important things about this modeling framework is to assign those kinds of things low but non-zero probability. So because that's the exact point, is that typically, like in traditional linguistic analyses, people would give rules for the productive things, and they say, well, those other things that you see occasionally that don't really happen, well, that just happens by analogy, or something like that, which is essentially a non-theory, right? Because what is analogy? Until you actually give a computational account of what it means to be analogical, then that's not a theory. So the whole point here is actually to capture everything in the same framework. So like another example is in the past tense stuff that I didn't talk about. If you take a nonsense verb, you say spling. Today he splings the DAX. Yesterday and you ask people to do this, they generally say splinged. But occasionally, what's that?
Spling, splang, splang.
Yeah, so occasionally people say splang, occasionally they say splung. But they...
Occasionally.
but this is the point, actually. This is an important point, because they do occasionally produce these things. They're at rates that are extremely low, but non-zero. And there was always sort of a tendency to hand wave about these and say, well, yeah, okay, so there's a rule for the regular past tense, but there's no rule for these others. Or there's a rule for the others, but it strictly can't be applied. It exists, but it's not allowed to be used. It's forbidden. So this model does capture both of those phenomena. And actually, I didn't talk about this, but I actually get some of the rates of generalization of the non-generalizable forms correct as well. Now, there's a separate question, which is like, why on earth would you do it? And there's all, that's like, why on earth would you attend this talk, really? And why on earth, we don't have very good, we're starting to build computational models that actually look at things like linguistic choice, like say stylistic choice or pragmatic choice, but that's kind of a separate issue than the issue of like representing the possibility of generalizations in your grammar.
Did you run your experiments with native English only, or also with learners of English?
So I don't run experiments. I have colleagues who run experiments. And the experiments I talked about here, the sort of say the IV and IDI experiments, for instance, were run in the late 70s. I just pulled the data out to.
So the corpora you use, are they also made up of?
So there's different training corpora for each of the projects. For the English derivational morphology stuff, I constructed a training corpus. There's something called, CELEX. Are you familiar with this? A sort of CELEX lexical database. It was a database put together by some folks in Holland that has a pretty big sample of words, which for some of which there are some representation of the internal structure of the words, but it was kind of a mess. The other thing that also happens if you ever want to study productivity in the wild. These large number of rare event distributions lead to real big problems with sampling, because it's very, very, very hard to sample a large enough sample to actually see enough of these rare events. So in particular, CELEX, I think, has a frequency threshold cutoff of, I think, 16 million. You have to appear at least once every 16 million words or something like this in order to make it into CELEX, which is actually too high for doing good productivity studies, because you need actually the longer tail to do it. So Harold Bine actually has a whole book on these word sampling problems. Like, it's very, very hard to study linguistic. This is actually one of the big points that I think is seldom made but should be more often made about sort of very popular things in natural language processing, and sort of the new resurgence of neural network kind of stuff and whatnot, is that most of the interesting stuff that happens in natural language happens in the tail of the distribution. That is very that you basically see, even if you have these maybe if you're Google or something, but if you had even if you have massive samples, you sometimes only see these constructions once, and yet every native speaker knows it's fine. And so I had to run. I spent, first of all, I hand corrected 10,000 forms, which was god awful, and it took me months. But I also wrote special parsers that crawled through web pages trying to find candidate things with suffixes, and then I checked them by hand and put them in if they were, and then analyzed them. And so it was I built a corpus for this basically, which I should put online actually now that you mention it.
But here the problem is also that most corpora are based on written language, right, and not on spoken language, where it's also
yeah, that's true.
Usually
that's true.
A lot of productivity visible that is just used once, and it doesn't the people listening are not oh, what's that, but understand what the meaning is.
Yeah, that's right. I mean, it's so for instance, the fact that yun is so much more frequent than this is probably partially an artifact of that these data sets were built out of newspaper texts, you know, which tends to use a certain register more so. Like, and yeah, it might be more common even in spoken English. It's not clear. And there's also phenomena that you just don't see, like, you know, the phenomena during there's a particular linguistic phenomenon in the 90s, you know, whereby the suffix edge, age, was added to everything, and that
Like reportage.
yeah, but that's an actual word.
Yeah, okay.
It's more like oh, that beer is good. That's good drinkage. Yeah. I mean, I feel embarrassed when I say these things, but it was
So 90s.
It was like in the Midwestern United States in the 90s. This was like a very common, cool thing to do, and that surely didn't make it into any corpus. Nowadays, of course, it would all be captured. You know, Google has it all, of course, in GChat. But actually, I should go talk to those guys and get my hands on that data. But yeah, so there's like sampling problems. I mean, the general principles stay roughly the same, and like for things like Ness is so robustly attested, it's not really a problem. But
is it possible to kind of manually build a board, and could it be that, am I right that one output of these models could be a sort of a probability of this board kind of being correct? So
yeah, that's exactly what they produce. I mean, it's, amongst other things, that's exactly what they produce, yeah.
Okay.
So like when I did that systematic search over the various generalizable combinations that I said, like Asian and whatnot, I actually systematically searched over all the possible combinations and scored them. And so yeah, you can, yeah, so this is a you know, typical problem.
Sorry,
that
can you also
use.
give one part of the word, and the model gives you what are the most possible variations it
Yeah,
can build?
yeah,
Do
exactly.
you have examples of that?
And how long are you staying in Berlin?
I do. I mean, I don't have any off the top of my head. But okay, so first of all, most of those examples you'll find are very uninteresting because the most probable instances of any morpheme are the ones that are existing. And so if you ask me for an example of Ness, and you ask what's the most probable example of Ness, it's going to say something like business. And you're going to be like, oh, I knew that.
What about restructuring the model so that it pushes toward creating, like giving out the most possible new one?
Right, so that's actually what I did. I sampled, so that's possible, right? So for instance, again, that simulation where I did the Asian, looked through all those, I basically invented a new stem like WUG. And I systematically tested all of those combinations probability as being attached to WUG, assuming WUG was, say, a noun or a verb or whatever. And then, but what you can also do is you can condition on the suffix and then sample in the position, also condition on the fact that the whole combination is novel. And I've run those kinds of simulations too.
Okay.
So,
And
yeah.
can you extend this novelty to a sentence as well, probability-wise? Like
Sure.
start sequentially just going with the most probable new structure?
You mean left to right through the sentence?
Yeah.
In principle. In order to do that, you have to compute something called the prefix probability of the sentence potential derivation, which requires enumerating over an infinite set of possible sentence completions, and so you have to use a special algorithm to do that. But it's which I haven't done, but I have an implementation of that could be used for that. Yeah.
And one more final question: if you have that, so this means that you can, like, by running that, you can generate novel sentences, right? Books.
Yeah.
Okay.
Yeah, books, exactly.
Story.
Yeah, monkeys and typewriters. You know, that's it, yeah.
But then the semantics, obviously.
Are they?
I think so. Oh, there's no semantics in.
There's no semantics.
So
Yeah.
it'll just be like grammatically correct gibberish.
Yeah. It won't even typically be.